according to Dr. G.S. Raju's YouTube.
We are looking at a procedure that really defines the phrase extreme measures in the history of surgery.
Welcome back to the deep dive. Today, we're not just looking at a medical procedure, we're looking at a piece of history. We're dissecting the biliopancreatic bypass. And I have to say, looking at the diagrams for this, intense feels like an understatement.
Oh, absolutely. This is structural engineering of the human gut.
It really is.
And you're right to frame it historically. The source points out right at the start that while this was done a lot in the past for, morbid obesity, it is rarely performed today.
Right.
So in a way, we're looking at the heavy artillery of weight loss surgery.
It's the break glass in case of emergency option, or at least it was. And that context is fascinating because it tells us surgeons were willing to completely rewrite the digestive map.
Totally rewrite it.
We aren't talking about a little lap band here.
Far from it. This is invasive, it's complex, and frankly, it's intellectually brilliant in a sort of brutal way. Our mission today is to really visualize this anatomy.
Yeah, we need to understand how they replumb the whole system.
Exactly. We need to understand how you can take a human digestive system, cut it apart, and then put it back together in a way that fundamentally alters how the body processes energy.
Okay, so let's get into the operating theater. Where does this all start? Where's the first cut?
Well, the first phase of the operation, it begins with the stomach itself. You have to address the reservoir first.
The outline mentions the resection of the stomach. Now, resection, that's not just a trim, right? We're talking about removing organ tissue.
Correct. This isn't a reversible band or anything like that. This is the removal of a specific extent of the stomach. They are taking a large portion of the organ out of the body completely.
And the immediate physical result is, I assume, obvious, volume.
Exactly. The stomach size has also been reduced. That's the most intuitive part. If you have a smaller tank, you just can't put as much fuel in.
But is this just a sleeve gastrectomy then? I mean, we see those all the time now.
It's similar in principle, yeah.
Yeah.
Restriction. But it's really the setup for what comes next that matters. By reducing the stomach size, they're creating this high-pressure system.
So you eat a little, you feel full immediately.
Right, but if we stop there, it would just be a restrictive procedure. The biliopancreatic bypass is named that for a very specific reason. The stomach is just the opening act.
Ah, okay. So the stomach reduction is just the bouncer at the door.
Perfect analogy.
The real craziness happens inside the club. So let's move to phase 2, the complex rerouting. This is where we get to the small bowel.
And this is where the anatomy gets radical. In a normal body, the small intestine is feet and feet of absorption highway. Food comes out of the stomach, and it just rides this highway for a long time.
Soaking up nutrients.
Soaking up everything. But in this surgery, the surgeon takes the small bowel, and they mark a spot for sectioning. But not near the stomach. They mark it, as the notes emphasize, all the more to the distal portion.
Distal. That's the key word here. We're not talking near the top. We're talking way, way down the line.
Way down. Think of the small intestine like a 20-foot-long conveyor belt. The distal portion is like the last few feet.
So they basically just decide to ignore the first, 75% of it?
That's a great way to put it, yeah. So they find this distal spot, and they cut the bowel. Now we have loose ends.
Right, and you've got to connect them somewhere.
Exactly, and this is where the bypass is created. There are two major connections to make. The first one is the gastroenterogenostomy.
Okay, let's break that down. Gastro, stomach, enterointestine. So we're connecting the new tiny stomach directly to where?
To that distal portion of the bowel we just marked.
Hold on, I want to make sure I'm visualizing this. Normally, food leaves the stomach, enters the duodenum, then the jejunum. It's a progression. You're saying they stitched the stomach directly to the end of the track.
Precisely. You are skipping the duodenum. You're skipping the jejunum. You're skipping the vast majority of the proximal ileum. Food drops out of the stomach and lands practically in the backyard of the colon.
Wow. It's like getting on the highway in New York and the first exit ramp is Florida.
That is a perfect analogy. You missed the entire East Coast, and all the absorption happens on the East Coast. By bridging the stomach to the distal bowel, you are physically denying the food access to the main absorption sites.
Okay, that handles the food's path. But we cut the bowel. We still have that other end, the one connected to the liver and pancreas. You can't just tie that off, can you?
No, absolutely not. That would be fatal. Which leads us to the second connection, the enteroenterostomy.
Entero to entero, intestine to intestine.
Right. We have this long stretch of bowel that we bypassed. It's still attached up top, and it's carrying all those digestive juices. the bile and pancreatic secretions. We have to plug that back into the system somewhere.
So where does it go?
It gets connected to the side of that main food limb, but even further down.
So we have two streams merging.
Yes, but, and this is so critical, they merge very, very far down the track.
This setup is wild, and that leads to the big question, why? Why go through all this trouble?
The answer is chemistry. This is where we get into the mechanism of action. We have to talk about those biliary and pancreatic secretions.
Which the source calls important for digestion of fat and protein. That feels like a bit of an understatement.
A massive understatement.
Yeah.
They're the heavy lifters. Bile from the liver emulsifies fat. It turns big grease globs into tiny droplets. And pancreatic enzymes break those down so they can pass through the intestinal wall.
Without them, fat is just passing through.
Exactly. So let's trace the path. You eat a cheeseburger, the fat and protein go in your small stomach, then drop into that distal bowel loop. But where are the enzymes?
They're in that other limb, the one we bypassed.
They're miles away, traveling down that bypass limb, the biliopancreatic limb. The food is on one track, the enzymes are on a parallel track.
So the burger is moving through the intestine completely undigested.
For the most part, yeah. It isn't being broken down chemically because the detergent hasn't arrived yet.
That's biological hacking. The body sees the food, but it can't unlock the energy because the key is in a different room.
And that separation continues for a long, long time. Remember that second connection, the enteroenterostomy.
The rendezvous point.
Right. That's where the two streams finally meet. But remember where we put that connection.
At the distal end, near the exit.
Exactly. So the food and the enzymes finally mix, digestion begins, but
they're almost at the finish line. They have no time.
bingo.
What?
You have reduced the window of digestion from 20 feet to maybe a couple of feet. There is physically not enough time or surface area to break down all that fat and protein and for the bowel to absorb it.
So the calories just pass through.
They pass through.
Yeah.
The source puts it very bluntly. This process is impairing the ability to digest food.
We are surgically creating a malabsorption syndrome?
We are. It's a controlled state of malabsorption. The body just cannot grab the calories before they leave the system.
Which brings us to the synthesis, right? This surgery is attacking obesity from two different flanks at the same time.
It's a classic pincer maneuver. Flank one is restriction.
The stomach resection. The tank is smaller, you feel full faster.
And flank two is malabsorption, the diversion of the secretions. Even if you eat the food, you can't process it efficiently.
It's ruthless. But when you impair digestion that severely, there have to be consequences beyond just weight loss.
Oh, absolutely. And that's the trade-off. If you aren't absorbing fat, you aren't absorbing fat-soluble vitamins, A, D, E, K. You can become severely deficient in protein.
So these patients are walking a metabolic tightrope for the rest of their lives.
They are. And that is almost certainly why, as the source noted, it's rarely performed now. It's too heavy a hammer. We have cleaner surgeries now that don't cause quite this level of malabsorption.
It's just so effective, but so high maintenance.
Incredibly effective.
Yeah.
But you have to admire the logic from a pure engineering perspective. It identifies the two drivers of obesity, overeating, and absorption, and it mechanically breaks both.
Okay, so let's recap this journey. We start with a stomach resection.
A big one. To create restriction.
Then we move to the small bowel. We cut it way down at the distal end.
Right. Then we take our new small stomach and connect it directly to that distal point. That's the gastroenterogenostomy.
Letting food skip the entire absorption highway.
And finally, we take the other limb, the one carrying the bile and pancreatic juices, and we reconnect it way down at the bottom, the enteroenterostomy.
Ensuring the food and the juices don't meet until the very last moment, which impairs digestion.
And results in massive weight loss.
It is a hell of a procedure. And honestly, walking through it makes you realize how resilient the human body is, that you can rearrange the plumbing so drastically.
It adapts. But it also highlights that digestion isn't just one thing. It's a symphony of timing and location and chemistry. You change the location, you change the outcome.
And this is the ultimate example of that.
It really is.
As we learned from Dr. G.F. Raju's YouTube.
Sometimes looking at the rare procedures teaches us the most about how the body actually functions.
I couldn't agree more. And here's a final thought for you. We've spent this time talking about mechanical plumbing fixes for biological problems. But with new hormone-based treatments hitting the market, things like Ozempic and Wegovy, are we looking at the end of the plumbing era? Will future generations look at a biliopancreatic bypass the way we look at bloodletting? Something to think about. Thanks for listening to The Deep Dive.